moving on into the next method of solving quadratic equations. Now we're going to solve these by factoring. So this combines a lot of what we did in Unit 2 with factoring either differences of squares or quadratic trinomials, and combining that in with solving quadratic equations. So as I've mentioned multiple times, factoring does become one step of a bunch of different processes we're going to deal with. This is one example. In order to do this, we have to rely on something called the zero product property, which says that if a times b equals 0, either a equals 0 or b equals 0. To put that into more friendly language, if we are multiplying two numbers and we get an answer of 0, one of them must have been 0. It's the only way we can multiply and get 0 as an answer. How does that combine with factoring? Well, we'll just go through the examples and you'll see how that works. So, question A, x squared plus 8x plus 12 equals 0. The key to solving by factoring is that we do need to have 0 on one side of the equals, which we do. Once we get that, we can worry about the factoring. We need to find two numbers that will multiply to 12 and also add to 8. Those numbers would be 6 and 2. So the way this works, we still factor this into x plus 6 and x plus 2. The only difference now is that this is a part of a quadratic equation and it does equal 0. So don't forget to add that on there. At this point, now we pull in that zero product property. We take a look and we say, well, okay, these two brackets, they multiplied, they equal 0. So it means either x plus 6 had to equal 0 or x plus 2 had to equal 0. Which now this gives us two smaller equations we could solve in grade 8. We need to get x by itself, so minus 6 minus 6. And we get a solution of x equals negative 6. Same thing on the right, subtract 2, and we get a second answer of x equals negative 2. This is exactly the same as we would have got had we solved these equations by graphing. In graphing, we would have seen these as the x-intercept, and by factoring, we just see them as equations like this, as solutions like this. Moving on to B, we equal 0, so we need to find two numbers that multiply to 25 and also add to negative 10. Those numbers actually happens to be the same number twice, negative 5 and negative 5. So that will factor into x minus 5 if x minus 5 equals 0. And we can actually take a bit of a shortcut here, since when we split this off, we know both of these brackets are going to split into identical x minus 5 equals 0s. So really, what's the point of doing it twice? We can do it once. We have one answer, and it's x equals 5. In terms of a graph, this would be a parabola that just bounces off the x-axis at one spot. Moving on to C, same method. Two numbers that will multiply to 8 and add to negative 6. Those would be negative 4 and negative 2. So the factoring is x minus 4 and x minus 2 equals 0. Split that off. So we have x minus 4 equals 0 and x minus 2 equals 0. Getting x by itself, we have x equals 4 and x equals 2. Example D, we need to remember that we have differences of squares that exist. We will see those from time to time. This one is a special type of factoring. Two brackets, the square root of each of those terms, so x and x. as well as 4 and 4. 1 plus, 1 minus. And because this is part of a quadratic equation, it does equal 0. Can't forget those differences of squares. They will pop up. Know that it's going to happen. Go ahead and split this. We get x plus 4 equals 0 and x minus 4 equals 0. Getting the x's by itself, x equals negative 4 on the left, x equals 4 on the right. Moving on to E, we cannot do question E at the moment. We do not equal 0. So we need to actually move this 21 over to the other side. We'll subtract 21 from both sides. With no like terms on the left, we're just going to be left with x squared plus 4x minus 21. And yes, we do need equal 0 because it is an equation. It stays an equation. Again, we're back to a trinomial, so we need two numbers that will multiply to negative 21 and add to 4. That would be 7 and negative 3. Splitting that off, x plus 7 equals 0, x minus 3 equals 0. On the left, x equals negative 7. On the right, x equals 3. Same deal on f. We need to move that 35. We'll subtract it from both sides. No like terms means x squared minus 2x minus 35 equals 0. We need two numbers that will multiply to negative 35 and add to negative 2. That would be 5 and negative 7. Splitting, x plus 5 equals 0, x minus 7 equals 0. Leaves us with x equals negative 5 and x equals 7.